Right, just staring at this diagram, pretty sure this is the three triangles that are all similar. Choose the two correct ones to set up a proportion. That idea is now getting confirmed because it says we've got a right triangle, EFG, and the altitude, which is creating right angles in the other one, intersects the hypotenuse. So now I know that this is the right angle, which means I am going to go through this process for this type of problem, which is draw the three triangles, figure out which ones you are going to use to set up your proportion. So big triangle is EFG. Small triangle, make sure you get the right angles in all of them, is FHG. Right angle over here, FHE. And let's start putting some lengths in there. FH is 9, so I've got 9 here and 9 here, which makes me think I'm going to use those ones. We got EF is 15. Which means that this is a particularly hard version of this problem, because usually what we are looking for is two triangles with two pairs of corresponding sides. So let me just label this variable. We're looking for EG, which is the whole thing. So I'm going to call that X. And my normal suggestion for you, maybe this is not that hard. I'm getting thrown off. So one of the things that I do when I get thrown off with these ones is I'll just label a couple more angles, because we've got this angle right here, which is the reflexive property in both of them. And so what I'm trying to figure out is, yeah, something weird is happening with this one. So what I see now that I labeled that is that this side right here, which is length of 15, that side corresponds with this side, which we do not have right now. And the hypotenuses correspond with each other. So across from the 90-degree angle, this side corresponds with this side. So this is the most annoying version of this type of problem. What you have to do is solve for the missing side here first. So these are all right triangles, and it's only the trickiest versions of these where you have this additional step complicating what's going on. But because that's a right triangle, I can do the Pythagorean theorem. A squared plus b squared equals c squared. The 15 is the hypotenuse, so that has to go there. And on the other two parts don't matter because you're adding them, so it doesn't matter which order you do it. So I get y squared plus 81 equals 225. Subtract 81 from both sides. Is that 144? Certainly looks like it. 225 minus 81 is 144, which is nice because I know the square root of 144 and the square root of both sides, so I get that y equals 12. So now I'm going to head back over here and put that 12 in. And now I'm actually going to be able to set up this proportion. So as I'm going from one triangle to the other, I like starting with the hypotenuses. So this is 15, and that turns into the hypotenuse in the other one. And this side is the one that's in between those two angles. That's 12, and that's going to turn into the one that is in between the two angles over there. And I wonder if there was a shortcut. I guess you could have gotten rid of two answer choices just by knowing that this is the hypotenuse of this triangle. So it couldn't be that, and it couldn't be that. So I'm halfway there already, but now I'm going to cross multiply. 15 times 15 equals x times 12. get 225 equals 12x. Divide by 12 and should have my answer. 225 divided by 12, 18.75. Pretty rough one. I actually thought about taking that off your test just so you could have one of the more traditional ones, but that's what the Regents does to you sometimes. I do just want to point out that you could have done this a different way. You did need to find this side, but you could also do trigonometry here, so you could have solved for this angle, or you could have solved for this angle over here, because you've got two sides in the triangle, and then once you've got some angles, you could have just continued doing trig, but this is traditionally a triangle similarity problem, just the really hard version of it.